Okay, so this one here is about the arrivals from China, and we've really got to discuss why this drop-off. Okay, just a general comment. You need some sort of introduction. This data was collected from between the years, whatever years that was collected between, and it shows the arrivals to New Zealand. Intro done. 2 sentences. Okay, this person has plotted the seasonal effect correctly, no problems there. Predictions, brilliant. Now, without sort of reading it out to you, she's gone straight into, I'll just read that first sentence. There is a spike, sharp increase from the start of the year 2001. So she's gone and looked at it quite narrowly straight away. What I would say is overall the trend is increasing. So you need to comment on the overall trend. And without showing you the graph, you can picture it, the overall trend is increasing. Then you can break it down and say for a period and highlight where it is decreasing. But nowhere in that paragraph does she say what the overall trend is. She talks about the trend of 2 or 3 years, increasing, then decreasing, then increasing, or she needs to state the overall trend is increasing. Then you can break it down. Just a misconception. There's a sentence here, the very first sentence for seasonal effects says, the seasonal pattern of arrivals from China to New Zealand is very varied, which can be a result of the earlier significant spike and trough trend. The seasonal effect isn't varied at all. The seasonal effect is just that. In summer, there's a spike. In autumn, it sort of comes back down to mean. And in winter, we have below the mean, which is the 0 line. And then coming back into summer, the arrivals start to pick up again. So the seasonal effect repeats. I mean, if you look at this graph over here, okay, compared to a lot of the ones we've looked at, it is quite varied, but we do have some pattern happening for the seasonal effect. So it's not the seasonal effect isn't varied. There is a seasonal effect within this graph, and you only have to look at the raw data and see that the shape is repeating itself over and over, which is the seasonal effect. So that was just a small maybe misconception there, but for the rest of her discussion here, brilliant. And I'll just tick one thing here. I think the reason for the spike in February reaching 1,500 more arrivals than average is most likely due to the Chinese New Year, which, although is varied, usually takes place in February. I really like that comment. Okay? Particularly that bit, reaching 1,500 more than arrivals than average, because that 0 line is the average. Okay? That's seasonal effects. Now, residuals. I will read out her residual comment to you, and there's one sentence you can see I've added in here that you could actually learn and put into all answers on residuals. Residuals are not very large compared to the range of raw data around 10,500 people, and she's shown her calculation. Majority of the residuals fall in the range of plus or minus 1,000 people. Brilliant. And then I've just added in there, which is less than 10% of the raw data. Less than 10% is considered a low residual, and in brackets, a good prediction of the raw data. There are, however, peaks in January for the years 2010, 2011 and 2012, and January of 2012 saw a peak of 2,500 arrivals above their prediction. This is 23.8% of the raw data range, which shows quite a large residual. Very, very true. Over the course of 14 years, it seems that at the start the number of arrivals from China predicted was too high, as there was a number of troughs, while during the end, especially from 2010 to 2012, the number predicted was too low, causing the peaks. Excellent. Okay, and this next table is what I was discussing with you yesterday, and there is quite a few misconceptions here. If you look at, I'm not concerned about this number here. 10,500 is the raw data range. Excellent. The trend, and I'm just going to show you this on the graph, I've quoted as 2,000 to 4,000. Now watch closely, because what she did was 500 to 9,000. Go back up to the top. Why isn't it letting me go back up to the top? Okay, I'm going to draw another picture that just illustrates, I'll exaggerate what she did. So, so the raw data looks something like this, okay? Okay, things are jumping around a bit here. Here we go. So that's, you can see the raw data behind here. So she's taken the range as this point, sorry, the range of the long-term trend from this point to this point was 500 to 8,000. Okay, and it's difficult to see on this graph, but really the long-term trend range is the best fit line, and that's the range. So I took, remember, I took between 2,000 and 4,000. That's probably not right either. Yeah, and that's probably because I actually brought the line through there. So this, you can see why it's such a, it says average component, it's approximate component rather, because it's quite argumentative. Do I take that, the trend component through there? Do I take it up through there? And it's really that value minus that value for the trend component. And for the numbers that I put in there were 2 and 4, which is probably, it should be really 2 and 6. Where's 6? Here's 6. Do you agree with me? 2 and 8. Well, let's just think about it for a moment. Oh, really interesting what's going on with my screen here, but so I've put 4. Oh dear. Let's go back down to here. I've put 4. Some people said it should be sort of 6 to 8,000. Ignore that for a moment. We'll come in and put that percentage in there in a minute. But what's easier to do is the range of the seasonal component minus 1,000 to 1,500. And that works out to approximately 20%. No problems there. This one's easier to do. Look at the residual graph. Minus 1,000 to positive 2,500. Range 3,500. Now, you'll see in there, I've crossed out her 23.8 because look, it's an approximate contribution, and I've changed it to 25%. And you can see how varied this is based on this the trend component. So let's argue that the 20 and the 25 are approximately right. That would mean that this one would have to be, or the trend component would have to be 55%, so that we end up, because remember, raw data must equal trend plus seasonal plus residual. So there's only 3 components and they have to add up to 100%. Okay, and she's made a comment down here about that table, but of course it's all wrong because she worked it out to be 81%. It's much less than 81%. It's in the order of sort of 40 to 50%. Okay, and then I want to discuss the conclusion for a minute. I've just given some ideas on how to structure the conclusion, and you can all rote learn this as well. You should start with after a visual inspection and then finish the sentence. The best one is on page 33 of your workbook. After a visual inspection of the plot showing predictions, I am confident that the model provides a good fit as differences between the fitted data and the raw data are non-existent or very small. You could rote learn that sentence. Done. The second sentence the second paragraph rather, should deal with some predictions. I predict that, and then basically choose a couple of predictions from this table. That in May 2012, the arrivals from China to New Zealand will be 8,000. And don't give me the decimals or the 407, just give me 8,400. It's a prediction. You can't be too concerned about the decimals or even the ones column. And then you might want to just have a look down here and look for maybe one that looks a little bit out of place as a prediction. The best thing to do actually is to go and look at your graph of the predictions and maybe choose one that's out here where the margin of error is quite large. Notice the margin of error, as the further away you gets larger. So give me one of those and then discuss any exclusions, and any exclusions to your predictions, and this is where you would highlight the fact that there was a big drop off in, I think it was 2008. So it segues nicely into any unusual features of the graph, and in China's case there was a very unusual feature, and you could discuss why that feature occurred or some suggestions as to why that feature occurred.